this video, let us study about action of heat on boric acid. So well, we know the formula for boric acid is H3BO3. So this boric acid is heated at a particular temperature. So what is the temperature? 373 Kelvin. So when boric acid is heated at 373 Kelvin, you get metaboric acid HBO2 and water. So boric acid, you are heating to 373 Kelvin or 373 Kelvin, you get metaboric acid HBO2 and water. Now this metaboric acid HBO2, you are further heating to high temperature of 413 Kelvin. So there you get tetraboric acid H2B4O7, that is tetraboric acid. S plus water. Now let us see the balancing of this reaction. So in the first reaction, H3BO3 gives HBO2 plus water at a temperature of 373 Kelvin. So that is metaboric acid HBO2. So now here 3 hydrogen on the left hand side, on the right hand side 3 hydrogen, and left hand side 1 boron, right hand side 1 boron, and left hand side 3 oxygen, and right hand side 3 oxygen. So it is balanced. So first reaction of boric acid heating to 373 Kelvin gives metaboric acid and water. So that is balanced. Now let us look at the second reaction. Metaboric acid again heated to 413 Kelvin gives you tetraboric acid plus water. Now let us balance here. So on the right hand side boron is 4, whereas on the left hand side boron only 1 boron. So I just put here S. Now 4 hydrogen on the left hand side, on the right hand side S. Hydrogen, 4 hydrogen is there. Now oxygen on the left hand side 8 oxygen is there, on the right hand side also 8 oxygen is there, so that is also balanced. Now in the third reaction, this tetraboric acid again further heated to red hot. As high temperature becomes red hot. So H2B4O7 is tetraboric acid. Tetraboric acid further heating to red hot, you get boric anhydride B2O3 plus water. So tetraboric acid you heat it to red hot, you get boric anhydride plus water. So now let us balance this reaction. So here 4 boron is there on the left hand side, whereas on the right hand side 2 boron. So I just put here 3. So balancing, so now it becomes 4 boron. Now hydrogen, on the left hand side only 2 hydrogen, on the right hand side also 2 hydrogen, so it is also balanced. Now in the case of oxygen, left hand side 7 oxygen is there, right hand side 2 3s are 6 plus 7 oxygen on the right hand side also. So reaction is balanced. Okay, so that's it about your action of heat on boric acid. Boric acid heated to 373 Kelvin, you get metaboric acid and water. Metaboric acid further you heat it to 413 Kelvin, you get tetraboric acid, and tetraboric acid further heating to red hot, you get boric anhydride along with water. So that's it about your action of heat. Now let us look into the next one, action of ammonia. Yes, so here boric acid. So boric acid can be also written like BOS thrice. So you are heating with ammonia at a temperature of 800 to 1200 Kelvin. You get boron nitride, Bn, boron nitride. Yes, so Bn is boron nitride. Yes, so boron nitride along with water molecules you get. So boric acid reacting with ammonia in the presence of high temperature, that is 800 to 1200 Kelvin, temperature or heat is applied and you get boron nitride and water molecules. Okay. Now let us balance this reaction. So here 3 boron, here only 1 boron, here also 1 boron. Here oxygen 3, here it is only 1 oxygen. So I just put here 3. Now hydrogen, here it is 3. And here it is 3, so 6 hydrogen, so here also 6 hydrogen. Yes, and here 1 boron, yes, 1 boron, here 1 hydrogen, 1 hydrogen, so it is balanced. Yes, so boric acid react with ammonia at a high temperature of 800 Kelvin to 1200 Kelvin, gives you boron nitride along with water molecules. Fine. Now let us look into the borate test used to identify the boric acid or borate site. Presence of boric acid or borate by this test called as boric test. So how do we do this test? So boric acid react with ethyl alcohol. C2H5OH is ethyl alcohol. Yes. So in the presence of concentrated sulfuric acid only, this boric acid is reacting with the ethyl alcohol. So you get the product here, trialkyl borate. You get BOC2H5 3. Yes. So here C2H5 is nothing but your alkyl group. So and it is 3 times. So trialkyl borate you get along with water molecules. Now this trialkyl, if trialkyl borate is formed, then it goes with the green edge flame. So if the flame is green edge, then we can tell that yes, it is boric acid or borate salt. If it is not green edge flame, then it may not be boric acid or borate salt or some other salt. So this is the also called as flame test or borate test to detect or identify the presence of borate salt. So that is your borate test. Alkyl borate, which is obtained after the borate test. So this is reacting with sodium hydride NaH to give a coordination compound NaBHOC2H5 thrice. So I repeat, the trialkyl borate, which is an ester, which is obtained by the borate test. So this ester, trialkyl borate, is reacting with sodium hydride NaH to give a coordination compound, that is NaBHOC2H5 thrice. Now this coordination compound is a powerful reducing agent. Fine. Now let us see the next one, that is how boron trifluoride is formed from boric acid. So this boric acid, it reacts with calcium fluoride CF2 in the presence of concentrated H2SO4 to give calcium sulfate and boron trifluoride BF3 along with that water molecules also. So this is the formation of boron trifluoride. Boron trifluoride formula is BF3. So how is boron trifluoride obtained from boric acid? Boric acid is reacting with calcium fluoride CF2 in the presence of concentrated H2SO4 to give boron trifluoride and calcium sulfate and water. Now let us balance this reaction. Here calcium, you see calcium only one on the left hand side, right hand side only one, so that is balanced. Now boron one on the left hand side and one on the right hand side, that is also balanced. Now sulfate one and on the left hand side and right hand side also one, that is also balanced. Now fluoride, it is 2 on the left hand side, whereas here it is 3 on the left hand side. Yes, so what will I do? I just put here. Yes, now it becomes 6 fluoride. So I put here. Yes, now calcium is 3 here, so I just put here 3 calcium. Yes, so now here sulfate will be 3, so I put here 3 sulfate. Now here hydrogen, it is 6 hydrogen, whereas here only 2 hydrogen, and here 6 plus 3, 9. So here boron, 2 boron is there. So here only 1, so I put here 2 boron. Now let us see into the hydrogen here. Here it is 6 hydrogen and here 6 hydrogen. So it is 12. So I put here 6. Now let us look at the oxygen here. Here it is 6 oxygen here and 12 oxygen here, so 18 oxygen left hand side. Now right hand side, we see how many oxygen. So 3 4s are 12, 12 plus 6 oxygen, 18 oxygen. So now it is balanced. boric acid react with calcium fluoride in the presence of concentrated H2SO4 to give boron trifluoride and calcium sulfate along with that 6 water molecules also. Now let us see how boric acid react with soda ash. So this soda ash is sodium carbonate Na2CO3. So boric acid react with sodium carbonate to give borax Na2B4O7 plus carbon dioxide gas and water molecule. Now let us balance it here. So here on the right hand side boron, 4 boron is there in the borax. So here on the left hand side only 1 boron is there, so I just put here 4. Now sodium left hand side 2 are there, right hand side also 2 atoms are there, fine. Now carbon left hand side 1, right hand side also 1. Now let us look into the hydrogen on the left hand side. Left hand side 4 3s are 12 hydrogen, whereas here only 2 hydrogen. Yes. So what will I do? I put here 6. So it is balanced in the case of hydrogen. Now let us see in the case of oxygen. Oxygen also 12 oxygen plus 15 oxygen on the left hand side. Now on the right hand side we will see 6 oxygen, then 8 oxygen plus 7 oxygen, so it is 50. So that is also balanced. Yes. So action with the soda ash, boric acid react with the soda ash, that is sodium carbonate, to give borax and carbon dioxide gas with the 6 water molecule. Yes. Now let us see the uses of boric acid. So boric acid is used in the manufacture of pottery glazes. So the shining coating which gives glazes to the pottery. So that is nothing but a pottery glazes, and it is also used in manufacture pigments and enamels. Pigments means dyes of different colors, and enamels. Yes, which is commonly used in jewelry enamels. Then it is also used in manufacture of antiseptic. So antiseptic can be an ointment or a cream, so which avoids the contamination or infection of certain microorganisms in bacteria, fungi, etc. Yes, so boric acid is used in the manufacture of antiseptic and also in the eye lotion. Yes, so the same, when it is used in the eye lotion, again it is acting as the antiseptic in order to avoid the contamination of the bacteria or the fungi or whatever. Then it is also used in food preservatives. So food preservatives is the preservative substance which increases the shelf life of the food. Yes, so this boric acid is used as preservatives in food items. Fine. So that's it about your uses. So hope you understood this video. Fine. Thank you.